So if feedback is responding to a change in a physiological variable by producing more change in that variable, and if feedback can be positive or negative in nature, the next question to ask is, how does the body use positive and negative feedback? If it's responding to its environmental changes through feedback, then how does it use these two? Well, you should remember that I began the first video with the term homeostasis. Homeostasis is the existence and maintenance of the relatively stable internal environment within the body in the face of a changing external environment. Now, notice the word is not homostasis, it's homeostasis. And homo and homeo are not exactly the same root, at least in terms of their context. Homo means same, homeo means similar. So it's not homostasis, it's not same state, it's homeostasis, similar. The environment isn't constant inside the body, it's relatively stable. It changes incrementally, but it stays relatively close to an average value called a set point. So another way you can define homeostasis is to think of it as the dynamic equilibrium or changing balance about a set point value for a particular variable. And I keep using this term physiological variable. Let me be very clear. A physiological variable is anything in the body that we could measure clinically that varies or changes. So common examples include body temperature, blood pressure, blood sugar, blood pH. I could keep going very easily. Anything you can think of that gets measured clinically is a potential physiological variable. And homeostasis is about maintaining balance in those variables. So, okay, does homeostasis use positive feedback or negative? Well, given that our goal is balance, you should recall this figure from the last video. In negative feedback, when environmental changes occur, whether they are increases or decreases in a particular variable, negative feedback reverses them. And that means pushing them back towards set point, and that means maintaining balance. So homeostasis is going to use negative feedback. Now, just to throw this up as a counterpoint, let's remember what positive feedback looked like. In positive feedback, whatever the environmental change did to a physiological variable, positive feedback did more of the same. It amplified the change, and by definition, you can see in the figure, positive feedback pushes the variable away from set point. So positive feedback doesn't maintain homeostasis because it drives things away from set point. And a lot of the common examples we often use in classrooms to talk about positive feedback involve circumstances where positive feedback takes over for negative feedback and bad things happen. Blood pressure or body temperature drops so low that they begin a downward spiral, driving them further and further down to the point that the person has to have medical intervention. And those kinds of examples make positive feedback sound inherently bad, but that's not actually true. There are a number of processes that occur in the human body that once they begin, we need them to finish. Things like formation of a blood clot or childbirth. Those are just two simple examples. So positive feedback will be used in the human body not to maintain homeostasis, but to drive to completion processes which need to be driven to completion before they stop. So homeostasis is the existence and maintenance of a relatively stable internal environment in the face of a changing external environment. It uses negative feedback to maintain homeostasis, the body does, but the body also uses positive feedback to drive processes to completion, which leaves us with the final question here. How do we accomplish all of that?